This is one of the problems we did in class today, so I'm going to go ahead and work it out so that you can see how I did it. So the first thing I did was include my table here. Notice that in my table, I kept PO4 and SO4 together. I did not split them up because phosphate is a polyatomic ion and sulfate is a polyatomic ion. So I know y'all get to keep the polyatomic ion charts near you, open on another tab, or you have one out next to you, but you still need to be able to recognize what they look like in an equation that you don't accidentally write P and O or S and O, because that will make balancing this a lot more complicated. So let's go ahead and count how many we have. We have 3 sodiums on the reactant side, 2 on the product. PO4. This is 1 PO4. This is what 2 PO4s looks like. If we had 4 PO4s, we would have a PO4 in parentheses and a 4 on the outside. Ca has 1 on the reactant side, 3 on the product side. SO4 is 1 on each side. Okay, so let's start with Na. 3 and 2. So I'm going to use the least common multiple to get both sides to equal 6. So sodium on the reactant side needs to be multiplied by 2, and sodium on the product side needs to be multiplied by 3. So let's put that in our actual equation. So let's enter it in the equation. Sodium on the reactant side is being multiplied by 2. So let's show that. And sodium on the product side is being multiplied by 3. So let's include that as well. Now remember that the 2 gets distributed to both parts of our compound. So yes, we now have 6 sodiums, but we also have 2 PO4s. And over here on the product side, we have 6 sodiums, and we now have 3 SO4s on the product side. So now let's correct calcium. Let's go ahead and balance that. We have a 1 and a 3, so let's multiply the 1 by 3. So calcium on the reactant side is being multiplied by 3. Let's show that. And now we have 3 calciums and 3 sulfates. So we have 3 sulfates on each side, 3 calciums on each side, 2 phosphates on each side, and a total of 6 sodiums per side. This is a double replacement reaction. How do I know that? Because we have a compound plus another compound, and that produces a third compound and a fourth. We also know that because the sodium is now with the sulfate, and the phosphate and the calcium are now together. And you can check that over here. See, sodium and sulfate, and then calcium and phosphate. And finally, is this redox? The answer is not redox. How do we know that? There was no change in the charge. Sodium in this compound is +1, and phosphate is -3. If you weren't sure about that, we could also just swap the charges back. So there's Na3, and then it's PO4, and there's just one of them. So remember, there's a 1 out here. So the 3 would go back to PO4, and the 1 would come here. That's how I got 1 and -3. The same can be done here. That's +2 and -2. Now, on the other side, sodium is still +1. Sulfate is still -2. And here, calcium is still +2. Sulfate is still -3. So no charges have been changed. This is not redox. In this one, in the presence of a catalyst, gold and chlorine gas will react to form solid gold 3-chloride. So gold and so we're going to put a plus sign, chlorine gas. Okay, chlorine gas is Cl2, and I'm going to put a G after it. Now, why is it Cl2? That's because this is one of our 7 diatomic elements. Remember Brinkelhoff? This is one of those. So if you don't put the 2, this is not correct. Will react to form, so that's an arrow, solid gold 3-chloride. And it looks like this, with the S meaning solid. How did I know gold 3-chloride was AuCl3? That's because gold is Au, chloride is Cl. The Roman numeral tells me that the charge of gold is +3, and I can look at the periodic table to find out that chloride is -1. Swap the charges, and I have AuCl3. Finally, let's balance the equation, and it will end up looking like this. 2, 3, 2 are the coefficients. This has only one product, so we know it's a synthesis reaction. And is it redox? Well, it is redox. And how do we know that? Let's check. An element by itself, like gold or Cl2, they're not bonded to anything else. It's just Au and Cl. They start with a charge of 0. But over here in this compound, we know that gold had a charge of +3 and chloride -1. So gold went from 0 to +3, and chloride went from 0 to -1. That means that the gold lost electrons and therefore was oxidized, and the chloride gained electrons and so was reduced. Now for this one, I want y'all to pause the video and try it on your own. Press play when you're ready or if you get completely stuck. And here is the answer. Now, what type of reaction is this? You know it. Synthesis. This is also redox because we have a charge of 0 and a charge of 0 because they're elements by themselves, and then they become +1 and -1. Okay, here, pause the video. Here's the answer. Next one. Try again, pause the video. And the answer is, and the type of reaction is synthesis. Finally, we have this one, Al plus CuCl2, and I hope y'all can do this one. Go ahead and press pause. The answer is, it looks like this. The type of reaction is single replacement, and this one would also be redox. I hope y'all found this helpful. Please let me know if you have further questions, but otherwise, thank you for watching.